Section 3.6 of the textbook it discusses the concept of a point-slope form. So we're going to go through a few examples, and this is one of them. Given a line and a point on that line, they are asking you to write an equation for that line using the point-slope form. So the point-slope form is y2 minus y1 equals m x2 minus x1. So that's the formula for a point-slope form on a graph. So now let's look at number 13 here. So we're going to focus on this guy right here, right in the middle. So the question is, what do we know and what do we not know? Well, we have a point. We have a point -2, 3. So let's just call that out. So that's right here. So they give us our point -2, 3, where -2 is x and 3 is y. So theoretically, we could plug those into our y1 and our x1 values right here. So let's just do that. So let's say, and actually, we should say y minus y1, not y2 minus y1, simply because now I'm getting this confused with the slope. So let's just change that. And so now let's work through this. So let's replace our y1 and our x1, and we get, as a result, y minus the value of y1, which is 3 here, equals m times x minus the value of x1, which on this point is -2. So now we have part of the formula. Now let's keep going. So we still don't know this piece right here, m. We don't know the slope, but we're given a point on a graph and we're given a line that's already drawn for us. So we could actually figure out what the slope is based on a couple of points on this line. So let's look at the line, and I'm actually going to erase this underline here just so that we can see things better. So if we look on this line, we see we have this point right here, and then we can look for another point that crosses through in a nice clean number. So we could use this point right here, or this point right here, or even this point right here. The ones in between are a little bit more difficult to estimate where they actually fall on the graph. So we're just going to pick ones that kind of fall with whole numbers on the graph. And if we pick, let's say the first two, so this one and this one, and we can actually determine the slope simply by figuring out what the rise is from one point to another. So we can actually sort of draw a right triangle here and figure out that the rise is 2 squares, which is basically 2 units, and the run is 1 unit. And we know that the graph is going in the downward direction, which means that it's actually a negative slope. Had it been going in the other direction, it would have been a positive slope. So if you look at number 15 below here, that's a positive slope. So we know the slope is negative. So now let's determine the slope. So the slope is m is rise over run. So the rise is 2, and the run is 1. And we know that the slope is negative because it's going in the negative direction. So we can actually rewrite this as just -2. So now if we go back to our equation, we can plug this in to m. So y minus 3 equals -2 times x, and then we can rewrite this part as x plus 2. And that is our equation for the line and point slope form.